Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the strength of bases. In our last lesson, we discussed different definitions of bases in terms of the Arrhenius, Bronsted-Lowry, and Lewis concepts. We also talked about the general properties of bases. In today's lesson, we will define strong and weak bases. We will distinguish between strong bases, alkalis, which are soluble, and weak bases. We will also define concentrated and dilute alkalis and discuss safe practices for working with bases. Let us get started. Students, do you remember discussing strong and weak acids several lessons back? Both acids and bases can be classified using these terms. They are considered to be strong or weak depending on their degree of ionization or dissociation in aqueous solution. Strong bases are those which ionize completely or almost completely in water solutions. Some examples of strong bases include hydroxides of alkali or group 1A metals and lower members of alkaline earth metals. Lithium hydroxide, sodium hydroxide, potassium hydroxide, and barium hydroxide all fall into the latter group. When lithium hydroxide dissociates, it forms lithium plus and hydroxide ion. When potassium hydroxide dissociates, it forms potassium plus and hydroxide ion. Weak bases are those which ionize or dissociate only partially or slightly in aqueous solution. Ammonia and calcium hydroxide are both examples of weak bases. This equation shows the dissociation of ammonia. As you can see, when it dissociates with water, ammonium and hydroxide are produced. The double arrow indicates that the reaction does not proceed to completion. In fact, this is true of all weak bases. An aqueous solution of a weak base only contains a small number of ions that are derived from the dissociation of the base and a large amount of the non-ionized base. Let us discuss an example. If we have a solution of ammonia that contains 0.1 mole of ammonia per liter, the solution will only ionize to the extent of about 1.3%. Students, we have just discussed strong and weak bases. Please define each of these terms now.
Students, let's get ready. Begin. Time's up. let's get back to our lesson.
Hello, everyone. I'm sure you had no trouble with this activity. Strong bases are those which ionize completely or almost completely in water solution. Weak bases are those which ionize or dissociate only partially or slightly in aqueous solution. Let us continue on with our lesson by discussing concentrated and dilute bases. These two terms are used when we are describing the amount of a substance that is present in a given volume of solution. We can describe this amount by using either the percentage of moles or the number of moles. Concentrated bases contain a relatively large amount of a base in a given volume of solution. In contrast, dilute bases contain a much smaller amount of a base in a given volume of solution. The concentration of a base is defined as the measure of the number of moles of the alkali or base dissolved in 1 liter of solution. Concentration can be expressed in terms of molarity or mole per liter. As we discussed, the more moles there are within a solution, the higher the concentration will be. For example, if one solution has 12 moles of sodium hydroxide per liter, and another solution has only 3 moles of it per liter, the solution that contains 12 moles per liter is more concentrated. The solution with 3 moles of sodium hydroxide per liter is more dilute. Students, it is important to note that even though a solution might be dilute, it can still contain a strong base. Likewise, even though a solution might be concentrated, it can still contain a weak base. Let us discuss some important precautions for handling bases. Strong bases can cause serious damage to plant and animal tissue if they are not handled correctly. Therefore, it is important to avoid direct contact with these substances and to avoid spilling them on your clothing. Concentrated ammonia solution, for example, can cause blindness if it comes into contact with your eyes. The word caustic is used to refer to substances that can cause burning. For example, sodium hydroxide is also referred to as caustic soda, and potassium hydroxide is also referred to as caustic potash. Both strong and weak bases can be corrosive. That is why you should always wear goggles, gloves, and a laboratory coat while working in a laboratory. Students, can you think of some other safety precautions that can be taken while working with bases? Please list as many as you can.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I wonder how many safety precautions you were able to name. Let us list them together. If a base gets spilled, it is important to clean it up immediately. If a base gets splashed onto your clothing, wash the affected area right away. If it splashes on your skin, flush the area with lots of water and then with a dilute solution of a weak acid, such as acetic acid, about 1% is plenty. If you accidentally swallow a base, drink 1 to 2% acetic acid or lemon juice immediately. Today, we learned about strong and weak bases. We also discussed concentrated and dilute bases. We learned about some important precautionary measures that should be taken while working with bases in a laboratory. In our next lesson, we will describe the uses of some common bases. And this brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.